Welcome to Talkin Science, where we dive into the stories making headlines in the world of science and space. I'm Matt Miller. Dr. Brad Tucker is here too. Brad, happy Tuesday.
How's it going?
Oh, mate, doing really, really well. Let's get the headlines in this, the 25th week of 2021. Flipping exoplanet thinking, who can see Earth? Venus volcanically active? New research from decades-old data says yes. And a new kind of supernova discovered. Brad, it feels like COVID has conspired against me again for another outing. The Canberra road trip has been scrubbed before it even began.
Yeah, look, obviously a lot has changed in the past few days in a rapidly evolving situation. And not everyone can go where they're intending to go, let's say, anymore, especially when you need to cross multiple states. I think Tasmania now has just completely drifted off and now is part of New Zealand and kind of hiding out over there, given how everything's folded. And South Australia, I've gathered, is no longer part of the Federation and completely ignoring every other state.
It was incredible just watching as we were driving down to Parkes, the iconic town of Parkes in West New South Wales. Just the reports that were coming in by the hour from Australia's ABC, just incredible. The amount of this Delta strain that is going around and how it's affecting everything. But we did get to experience the Newell Highway a couple of times in 48 hours, which was cool. Newell Highway, of course, known. Yeah, exactly. Newell Highway, of course, known to a lot of astronomers. It's Australia's astronomy highway. We went through Coonabarabran, past the Siding Springs Observatory, and of course Parkes as well. Didn't get in there, but I'll have more details about the plan at the end of the show. But before we get started, a quick reminder of the socials, Brad. We can find you on Twitter at btucker22. I'm on Twitter at Miramat86. And of course, Trekzone exclusively on Twitter. Plus, find our YouTube channel for the latest eps and on your podcast app of choice. And you can get behind the scenes goss and early access to all Trekzone podcasts by becoming a member today. Click the join button on any Trekzone video. Go to the Trekzone/support or put your phone up to the QR code on screen throughout the show. Brad, first up in our headlines. Operations are underway to save Hubble. Its payload computer has been on the fritz since June 13.
Yeah, and it's something that they thought or hoping would be a quick fix. It hasn't turned out to be that. And in fact, they do have a backup computer for the payload. Payload essentially being what controls the images, the data acquisition, and does the scheduling almost, the brains of the Hubble Space Telescope, connecting to those instruments. They do have a backup version of that, and they did switch the backup. They haven't actually turned the backup on since 2009, when they are essentially installing and testing it before the astronauts went away. That didn't solve it either, and they've realized now the problem is further upstream. That is both a good and bad thing. It's not with the payload computer, so which is a very critical part of the Hubble Space Telescope. They still haven't found exactly where it is, and so they're trying to not only diagnose where the problem is, but then fix it. And noting that in the past, if it got in a really big bind, we would have the space shuttle and the astronauts to fix it, which we no longer have. So it has to be done all remotely from Space Telescope Science Institute, which is in Baltimore.
Absolutely incredible. Well, hopefully that comes back. But in the meantime, as Jeff Bezos discovers, he's too much of a risk for insurers ahead of his space flight. And Virgin Galactic have been given clearance to fly passengers to suborbital space by the Federal Aviation Authority in the US.
Yeah, look, both of these really beating up, so to speak. With the practical aspects here with Richard Branson, this will affect others. You do get insurance when you go into space. Now, generally, this is the government covering their national agency, either for people or satellites or equipment. For private launches, you do get private launch insurance to cover the cost of satellite failures or rocket failures, something like that. The whole people travel space tourism thing is so new and it is so unregulated. No one's really willing to take the risk to cover it in the event there's an incident or, more likely and probably in some ways worse, longer-term effects that generate problems that then someone is responsible for. And so it's a real sign that even though this is really happening, it's very unclear what it means for the industry as a whole, and it needs to get ahead of it. Because with Virgin Galactic now having their license, they clearly also want to now send their first mission up which we do know will have Richard Branson on it, just like Jeff Bezos on his first one. But they both want to hit the ground running or flying, so to speak, with passengers really quickly and a lot. And so there was going to be a few of these other random hurdles they're going to have to pass.
Well, Brad, astronomers have identified stars where alien inhabitants would have a view of Earth in some fascinating new research.
Yeah, it's a really cool one because we talk a lot about the new planets people are finding, the techniques people are doing to find these planets, and how there's essentially a lot of them, right? I mean, there's thousands of these planets with tens of thousands of candidate planets out there now more. So the question is, well, if one of these was habitable at some point or is habitable, and if one of these had or does have life and could have had intelligent life, could they have seen and detected Earth? Flipping that equation, as you said, if we can detect them, could they have detected us? And more importantly, detected a planet that was habitable around a good star, in the right environment, and potentially having a civilization on it. So they said, well, what are these stars in the past 5,000 years when there's been some large fraction of human civilization across the world could have found us? And the answer is a lot of planets could have found us in that time period.
Well, this is extending our exoplanet research a bit, but instead of looking for worlds transiting across their star, astronomers are looking for ones that don't.
Exactly. They're looking for ones that are either the transit technique, or as he said, the lack of transit technique, by actually seeing some of the light that goes through the atmosphere as well, or skims through the planet, much like an eclipse. You can get a measurement of the environmental property of that star. And that's one of the big key things that we're doing nowadays, looking for the environmental conditions of the star. Does it have an atmosphere? If it has an atmosphere, what is that like? Does it have water? Is it breathable? All those little details, because that is really the clue as to, are these places that could host a life like that is hosted here on Earth?
Well, this research is pointing to 29 potentially habitable planets seeing Earth transit and are near enough to detect human-made radio transmissions.
Yeah, because again, that's the key thing, is what we do with these SETI searches. We look for artificial signs of radio intelligence. And we do know that radio waves go through space, but like every sorts of electromagnetic radiation, but it fades with distance. At some point, you're pretty much not going to really pick it up. And so they're saying, well, if again, in a technology that as ours, could you build a radio telescope like Parkes or some other that you could detect these signatures with? And again, the answer is there's actually a couple of dozen of these planets that could be habitable, could have formed life, and then could have seen the signs of a habitable planet with artificial signs, putting together the whole picture of what we do here on Earth in all these different searches.
And, I mean, you mentioned Parkes, but there's also Arecibo before it collapsed. That was Earth's most powerful transmitter. It was sending out radio waves to whatever it was studying, and you could, in theory, treat those as spam. It's just shooting out all these radio waves, and it could have been detected if there is an advanced civilization out there listening.
Exactly, it is powerful enough to be sent into these things. And when some of these first experiments were done with Arecibo, we actually hadn't even discovered another planet around another star. And the first one was only in '92. The first Earth-like planet was in '95. So it was actually, ahead of its time, with the idea that yes, they're probably still there. And so now that we know they're there, we know where they are. And B, and I guess C, we kind of know that they could be habitable or potentially habitable. These are the interesting things that get people thinking, well, what does this all mean for the search for and contacting of potential civilizations? Not necessarily now, but in the future.
Well, using decades-old radio data, Brad, researchers have found that some low-lying areas of Venus's crust are on the move.
Yeah, again, a really cool thing. Venus for a long time had this rap of being a dead, dry, boring place, and hot, I should say. But it's no longer the case in that we're really starting to realize that using this old radar data, maybe it is active. And when we active, we're talking about a planet that has lots of tectonic plates. That's the key to the activity. And these tectonic plates are driving volcanism on the planet, which could be quite influential, but also quite important in understanding a lot about its surface, its evolution, how it exists today. And we talked about this before with all these missions going to Venus. When we look at Mars, we look at Earth, and we get Venus, we get really different planets that are similar, but on different parts of the spectrum almost in terms of their habitability. And this is yet another sign, a particularly interesting part of the study with Venus, of it being kind of on the other end of the spectrum to Mars and more extreme than Earth.
Well, interestingly to me, Brad, is that we still don't conclusively know whether Venus is volcanically active. We think it is, but we don't know for sure yet.
Yeah, that's right. We haven't seen volcanoes erupt. We haven't seen lava on the surface, but we see evidence through the atmospheric conditions, through the ground, through the measurements on the surface, and now through this radar data of what it looks like on the surface being these potential tectonic plates. That is the really big thing we want to understand. We see volcanoes on Mars, but they're not active. We obviously know of our volcanoes here on Earth. Volcanism isn't actually a rare thing. We see volcanoes on Io, the moon of Jupiter. Now, that is driven by a very different process as well. And so this is the key. Are the volcanoes like on Mars, which are more similar to how, say, Hawaii was formed, not from hotspots rather than tectonic plate splits or cracks? Where does Venus fit in? Because again, it's not just about understanding Venus. It also tells us a lot about Earth and the activity and the rarity or how it behaves.
Well, the recent announcement of missions to our other neighbour will help shed some light on this and would mean that astronomers won't need to be using decades-old readings to make analysis. Some updated findings would be good.
Exactly. And this is one of the reasons you send these missions out, is that when you start reanalyzing a lot of the old data, you start discovering some new hints and new interesting things. Your knowledge has also changed since that data was taken. So when you go back and look at it, you realize, oh, that's what that is. A lot of these things definitely happen that way. And so now with all these new missions and new data they'll get, it'll really open up a new view of Venus. And I think more broadly, the rocky planets. And I think that's the key. We've really just focused a lot on Earth, obviously, and Mars, but now kind of bringing Venus up to speed, so to speak, will really help us in that more complete picture.
Well, lastly this week, Brad, a new type of supernova has been discovered by astronomers.
Yes, obviously something that I work on a lot with supernova, and this relates to a very interesting supernova called the Crab Nebula. And the Crab Nebula is a very famous naked eye, as we call it, supernova. It's always been a little bit hard to explain. And when we have supernova, stars that explode, they generally have two different types, what we call core collapse supernova, where you get a big star that comes crashing down on the inside and then explodes. We have what's called thermonuclear supernova, which is where you get a white dwarf, something our sun will be in billions of years, that either pools or sucks gas or atmosphere off another star or collides into another white dwarf. But now this third type, what we call electron capture supernova, was proposed about 40 years ago by Kindemoto-san. And now this new supernova that was discovered back in 2018 appears to match all 5 or 6 rather key characteristics of this, really confirming that, yes, there indeed is a third mechanism for stars to explode, which is, it's really exciting in our field. I remember from a baby astronomer hearing about electron capture supernova, which everyone's like, this sounds really cool and plausible. How do we see this? Are we ever going to see this? And now it appears to be the case that it's there.
A baby astronomer. I'm just trying to picture you as a baby astronomer, Brad.
Learning about all the cool explosions in space.
It is very cool research. Well, this one obviously focused on supernova 2018 ZD, and as you say, was confirmed by astronomers at the University of Tokyo. That was more than 40 years ago. So you've got to have patience when it comes to astronomical research, Brad.
Yeah, when Kindemoto came up with the idea that the Crab Nebula can be described as this electron capture supernova, again, it kind of made sense. We look at the Crab Nebula. And it is weird. It is different than we look at, say, Tycho supernova or Kepler supernova. These are very different ones in terms of what we see in terms of the ejection, the energy calculated, what's left over, the elements that are around. But, in our searching of thousands and thousands of supernova, we had never really seen conclusively an electron capture supernova. And then when they caught 2018 ZD, it had a very different evolution. So we can look at it, how its color changes. We can look at what elements pop up. And it really was dramatically different than the other two flavors of supernova, because everything has essentially a unique signature. And it was that really led them to say, well, maybe this is a different path. And as they started to dive into it and analyze it more and more, started to realize, yep, all of these things predicted 40 years ago that we weren't sure if we've seen matches to a T what we're seeing with this new supernova.
And the key in the research, Brad, is to witness it as it's happening. So unfortunately, no one is around from when the Crab Nebula was visible to the naked eye during the daytime, I believe it was, about 1,000 years ago. So that would have been an incredible thing to witness with a very limited understanding of what's going on. But as you say, 2018 ZD, providing that key ingredient to basically prove where the Crab Nebula came from.
Yeah, exactly. And it is really this big exciting thing because when they caught it, it's calculated within about 3.5 hours after explosion, which is quite early. You get to see very early bits of the initial stages of the explosion, which give you big signatures or keys as to how it's evolving and how it's exploding and the energy present. And as you said, even though the crab was very bright, we didn't have the telescope around there, so we didn't have those observations. So it's a very exciting thing to now be able to have this and link to a very famous supernova.
Absolutely incredible research, Brad. Well, just before we go, a quick check-in on the plan now that we can't travel for the time being. It'll still be a week-long Talkin' Science Fest as we celebrate NAIDOC Week here in Australia, a chance for us to celebrate the history, culture and achievements of Aboriginal and Torres Strait Islander peoples. We'll learn about the traditional name given by the Wiradjuri elders to the Parkes Radio Telescope, head to Questacon to learn about their key role in promoting science and learning to kids. And one I'm very excited for, we're heading into the Operations Centre at the Tidbinbilla Tracking Station to learn more about how NASA's Deep Space Communication Network operates. We sadly won't be able to chat with Dr. Graham Walker and see his teddy bear cannon fire, but we will be checking in with Southern Launch Australia following their recent approval to build the launch site at Whalers Way, which we talked about last week, Brad. So plenty of stuff to come. All of that will be back on video calls with the full Talkin' Science Fest playlist as a card here on YouTube or in the Talkin' Science section on our website. Brad, it is great to pick apart the stories of the week with you, and we'll do it again next week.
Thanks.
Keep up to date with Twitter. Catch new podcasts daily on YouTube. Plus, we're beaming to your favorite podcast app 5 days a week. Just search for Trekzone and subscribe.